Please kindly confirm if you can see my screen.
Perfect. I can see your screen.
Okay, so we start off. Good afternoon once again, gentlemen. Today, we are on the drilling fluid, basic drilling fluid course. And today we are looking at mud systems and additives. Mud systems and additives. Drilling fluid is the same thing as mud. We call it mud. Why? Because when you see it, you know that it is mud. You know that it is mud. It's like the mud, you know. But it's finer. This one, it's engineers that prepare it. So it looks slightly different than the other ones. Okay, mud systems and additives. That's what we are looking at. Yesterday, somebody asked a question of different types of mud you can use. For which, how do you choose the mud for a particular well? We are going to see how you can choose a mud system in this area. And also, we are going to look at mud additives. What and what do you use in preparation of your mud? Yesterday, we talked about incorporated solids and non-incorporated solids. Let me just read the introduction for you. Basic systems are usually converted to complex systems. Basic systems are usually converted to complex systems. Basic systems are usually converted to complex systems as a well deepens. As a well deepens, that means as you start drilling from the top, you make 10 meters of hole. As you're drilling down, the mud system is becoming complex. You start with a simple system, very simple one, but as you're going downhole, your mud system is being converted to more complex one. What we mean by more complex, more chemicals are added, more care is being taken, more technical and professional guidelines are being followed. As the well deepens, as well bore temperature and pressure increases, and formation changes, which requires some additional additives. Sometimes more than one system is used in the same well. What we're saying here is, as you start drilling with a simple mud system, maybe you use 5 chemicals to start with, but as you continue to drill, there will be a need to add more chemicals. There will be a need to reduce the use of some chemicals. There will be a need to stop using some chemicals altogether. There will be a need to adjust the concentration of some chemicals. There will be a need to add more additional chemicals. This is because as you're going down, the lower you go, the hotter it becomes. The lower you go, the higher the pressure. Pressure increases, and formation also changes. How does the formations change? When you are starting drilling, the top, you'll be seeing some sand. Initially, you may see some little clay as you start drilling. Then you see sand. From sand, you get clay. From clay, you get sandstone, lime, sandstone, claystone. And then you also get to shale. You get to sand again, sandstone, like that. The formation changes, temperature increases, pressure increases. So as these things are increasing, the formation is changing. You're meeting different types of formations. You have to also adjust your mud system. to meet those necessary requirements. Factors affecting choice of mode. Factors affecting the choice of mode. One of the factors is application. Application. First, under application, we're looking at surface interval, intermediate interval, production interval. Now, for every well you're drilling, it has these three areas, these three intervals. As you're drilling, when you start drilling, that's called the surface interval. Once you start to drill, we call it spudding, S-P-U-D-D-I-N-G, S-P-D-D-I-N-G. They call it spudding. As you start, it's called spudding. Once you spud the well, you're drilling the surface interval. The surface interval will be determined by the drilling engineer, the operator. He may say, we will drill from 0 to 1,500 meters, from 0 to 4,500 feet or 5,000 feet, and we will call it our surface interval. After that one, we cannot continue to drill that way because this particular interval, the formation is different. Sorry for that, each. After that interval, you drill to 5,000 feet, 2,000 meters, 1,500 meters. The operator, that's the oil company, they'll decide to case it and cement and say this is the surface interval. And then they'll drill another interval because you cannot just be drilling continuously a very long section. If you do, your hole will collapse, so many problems will come up. Then you have the intermediate interval. You continue to drill. Your target is the production zone. Your target is the reservoir. You drill prior to the production zone. You decide to stop and run a casing and cement it. What you have done is your well, you have given your well stability. Your well is stable. The integrity of your well is very sure. Nothing is affecting it. Formation pressure, fluid, nothing can affect it when you case and cement. And then you go to the production zone where your target of oil is. And when you're drilling that section, you're being careful. So the choice of mud system will determine in the surface hole, surface interval, what kind of mud system do I want to use? Likely I want to use a water-based mud, a simple water-based system. Intermediate section, what do I want to use? Okay, let me continue to use water-based, or I'm going to use oil-based. Production zone, how is it going to be? Am I going to do a case hole completion? Am I going to do open hole completion? With respect to that, you choose the mud, whether you use an OBM or you use enhanced water-based mud. So the choice of mud with respect to the application, surface hole, surface interval or surface hole, intermediate hole or intermediate interval, production interval. Also, the formation type, the geology or the lithology. The geology of the formation, you can also call it lithology. When you see lithology, also tells you the formation type, what kind of rock or what kind of soil is there. If you're drilling through a shale, if you're drilling through, or if you're going to drill through a shale formation, what kind of mud do you want to use? Having in mind that shale with water, they don't go well. Shale can easily absorb water, swell, and cause problem. In those kind of situations, you may want to use OBM. Since shale do not react with oil, you may decide to use OBM. Is the formation, is it sand type? Is it sand which is permeable? The permeability of sand, you know that is more than that of shale. Do you have sand there? If you have sand, what kind of mud are you going to use? And what kind of weighting material are you going to use? What is best in taking care of that permeability? You may decide I'll still use water base. Your formation, is it calcium carbonate? If it is calcium carbonate you're drilling through, what kind of mud will you use? Oh, I may want to use OBM. Is it deep? Is it intermediate? Is it the production zone? Also, if you know that there is salt in that formation, what kind of mud will you use? Will you want to use OBM or will you want to use WBM? If you're going to use WBM, then it's going to be salt mud, salt saturated mud. While in other places, it may just be ordinary WBM, but you're going to drill through salt formation. You can decide if it is deep, you can decide to say, okay, I'm going to use OBM or I'm going to use saturated salt system. Also, make up water. What type of water do you have that is available for you? Remember, you may be drilling in offshore, they don't have borehole there. You may be drilling on land, okay, you can drill a borehole. Is it possible to drill a borehole? Or will they be bringing water to the rig for you, like in offshore and swamp? They have barge that brings water, so water is very there. You don't have all the water you need. So as such, will you be able to do a WBM? If you're in offshore, are you going to, can you use the seawater? Will it be helpful to you, knowing that seawater does not mix with clay? You will not get any good results. The water you have, what is the chloride content? If the chloride content is very high, it will be a problem for you. If the chloride content is low, fine. If the chloride content is anything up to 1,000 milligrams per liter, then you know that you cannot use that water to start your spud mud. Hardness of water, calcium and magnesium. When you're mixing mud, to start, you start with bentonite, you start with water-based mud. The water you have, is it too hard? If it is too hard, your clay, your bentonite that you're going to start to mix the water, to mix your mud with, it will not give you viscosity. The viscosity will not come up. What type of water do you have? Is it fresh water? Is it brackish water? Is it salt water? All those things you will consider before you start to choose mud. And when you're considering those ones, it's at the planning stage. When you're planning stage towards to give the operator. There are other factors too, drilling data. What is the hole size? The top, the surface hole, what is the size? What is the angle? What are the temperature? What is the pressure? The intermediate hole, what will it be like? This one, the operator will give it to you. The temperature, the pressures, what are they like? So that you will know if the temperature is high, you will know the type of chemicals you will use. There has to be chemicals that can withstand high temperature. There are other factors too, limitations. Now, when we talk about limitations, what do you have enough tanks to mix mud? Now, when we talk about tanks to mix mud, you need a lot of volume. You are talking about 2,000 barrels of mud in circulation. 2,000 barrels of mud. Your hole, how much volume will your hole take? How much volume can you mix before you start to drill? Do you have enough capacity? Mixing capacity. Can you mix very fast? The rig, does it have all these things? Does it have good mud pump? The mixing pump, how is it like? Can it mix fast? Can you mix in 2 pits at the same time? This limitation sometimes or most recommended the mud company, the mud engineer or the mud company will send their rep to go to the rig and inspect the mud system. When we mean by the mud surface mud system equipment, they will check the tanks, the volumes, and everything, and they will come back and begin to plan. What are the solids control equipment? When we mean by the solids control equipment, you know, as you're drilling, you're bringing out the cuttings. What you drill will be coming out. You have equipment that removes all these cuttings and solids from your mud so that your mud can successfully go back to the hole and do the same work again. What are the solids control equipment do they have? How many shakers do they have? Is it 2 shakers or 3 shakers? Do they have a mud cleaner? Do they have a centrifuge? Do they have a settling pit? Those are the things you also need to consider. Contaminants. Now, when we talk about contaminants, are things that enter your mud from the formation. As you're drilling, these things are entering your formation. Solids are the greatest enemy of the mud engineer, because that is the reason why you have the mud, to remove solids and to remove cuttings. That's the reason for the mud. Remember, cuttings removal is one of the primary functions of the mud. What kind of solids are there? Salt. Are you drilling through a salt formation? If salt enter, how will you treat it? How will you handle it? Cement. If cement enters your formation, your mud, what are you going to do? Do you have the chemicals nearby? Is it available to treat it? If it is a water-based mud, what will you use? You will need to use sodium bicarbonate. If it is salt enter your formation, what will you do? You may need to dilute, you may need to start mixing your mud without salt. That's if you're not running a salt system. If you're running a salt system, you may need to increase your salt concentration in your mud. But if you're not running a salt system and the contamination of salt in your mud is not much, you may need to dilute. Acid gas, calcium carbonate, and hydrogen sulfide. Of course, you're drilling the formation, there will be gases. When calcium carbonate gas enter your mud, how is it going to affect your mud? Will your mud be able to remove it? What kind of chemical do you have to treat it? Hydrogen sulfide. We know that hydrogen sulfide is a very dangerous gas. It kills within minutes, few minutes, not plenty minutes, few minutes. What are you going to do? What plans do you have? The mud you're proposing, will it be able to handle hydrogen sulfide? What chemicals do you have in place to take care of hydrogen sulfide? One good thing about Nigeria is that we don't have hydrogen sulfide in our formations. And so we don't have that problem of hydrogen sulfide. Well, I remember when I was working in Gabon, we had hydrogen sulfide gas and we have to treat it. Everybody has to be trained on how to use the respiratory mask and cylinder. So these are the factors that affect the choice of choosing a mud system. Types of drilling fluid. Like we talked yesterday, there are a whole lot of drilling fluid. We have compressed air. Where do you use compressed air? Compressed air is used where you have consolidated formation that is very stable. Formations like rock. You can be drilling and the air will be blowing out the cuttings. You use compressed air. Instead of mud pump, instead of liquid pump, you use a compressor. a compressor that can give you enough pressure. As you're drilling, the compressed air will be blowing out. It will go through the bead, just like the mud goes through the bead. It will go through the bead and be blowing out the cuttings out to the surface. And of course, there will be a collection equipment. There will be a collection equipment that will be collecting these solids. They also use foam. Foam is used in areas where the formation too is very stable. And sometimes foam is used in a place where the formation is depleted. When we mean by depleted, it means that the pressure is not much and it is very stable. Clear water. Clear water can be used in drilling as a drilling fluid, especially some cases in offshore, where the well is deep, where the water depth is very deep. Water depth like 1,500 meters, they want to use clear water or seawater. They will just be drilling and be pumping the water out. And of course, they will also pump other viscosified mud to clean the hole. Clear water too can also be used to drill wells that are already drilled and everything is okay, and they just put some cement to plug a well that they are not ready to produce, but they have drilled it, and they put cement inside in just some maybe 50 to 100 meters cement to just keep it there downhole. They can decide to use clear water to drill it and use viscosified water to clean the hole. Then we come to mud. We have water-based mud, oil-based mud, and then we have synthetic-based mud. The water-based mud, the continuous phase of the base fluid is water. The oil-based mud, the base fluid or the continuous phase is oil. The oil could be diesel, it could be other kind of oil that is compatible with all the chemicals. It could be synthetic-based mud. Synthetic-based mud in the sense that it could be biodegradable, it could be mineral oil, like that. But the base fluid is non-aqueous. When I mean by non-aqueous, it is not water. Mud systems, we have fresh mud systems. Freshwater mud system, inhibited muds, water-based emulsion, oil-based and synthetic base. Freshwater muds, here we use fresh water as in the kind of water we can drink. The chloride content is very low. The hardness is very low. That's the magnesium and the calcium ions are very low. And they use this fresh water to drill. Simple freshwater system could be bentonite. Bentonite is a viscosifier. Bentonite, calcium carbonate, soda ash, caustic soda, and the rest. Sorry, can you just give me 5 minutes? I want to change the direction of my laptop. Okay, I'm back. I just want to, our NEPA people took light, so I decided to on my inverter so that I can still be having some, the fan rolling. All right, I talked about fresh water. So we use potable water for this purpose. Potable water for this purpose to drill. It could be bentonite plus fresh water plus caustic soda, soda ash, viscosifiers, weighting materials, and the rest. Inhibited mud. When we talk about inhibited mud, we are talking about mud that we add chemicals. The mud will inhibit the formation. For example, we have chemicals that will react with the clay or the shale and will not allow the clay or shale to swell. It will remove the water content from the clay and make the clay not to swell. We talk about water-based emulsion. Water-based emulsion is molds that have some little volume of oil. They make it in such a way that it's like our paint. Think about our emulsion paint we use in painting our houses. That is how it is. They put all manner of chemicals in it so that it becomes viscous and it has some little volume of oil in it. We call it water-based emulsion. Then we have the oil-based and synthetic molds. These are pure. When we talk about oil-based, does not mean that it is pure oil altogether. We still have some volume of water. The water is very necessary. The water is very necessary because we have other chemicals that must mix with water inside. Freshwater mods. We want to look at some freshwater mods. Spud mud. Spud mud is the first mud, like I told us, is the mud that we use to start drilling. That mud that is used to start drilling is called spud mud. It's called spud mud. It's called spud mud. It is a very simple mud. Very simple mud. It's just water and bentonite, caustic soda, soda ash. Sometimes you have your LCM, loss circulation materials to take care of losses so that you don't just lose your mud into the formation like that. So we have spud mud. We have spud mud. Then we have low solid mud. Now these low solid muds are also low weight mud. Simple mud with their mud weight is very, very low. The amount of solids in it is very low as well. We also have lignite muds. Lignite muds are muds that are used with respect to the formation you are drilling. With respect to the formation you are drilling. With respect to the formation you are drilling. Lignite also has its own work and function to do. It disperses. It helps to reduce your viscosity to some extent. And it also gives inhibition. It also adds to weld stability. Then we have lignite surfactant mud. Lignite surfactant mud. This lignite surfactant mud You know, surfactants are things like, let me use the layman language, things like detergent, things that have a surface acting qualities, such that you have a surfactant in a particular place, it will help clean that area. Like a soap, let me just use the word soap. Those are lignite surfactants. The surfactants you add to it and it will help clean the well. You have lignosulfonate mold system. With time, you get to know all these things. But these are just the basics of some different types of mold. You have lignite sulfonated mold. But in Nigeria, most of the mold we use as water-based mold, spud mold, low solid mold, some lignite mold, some asphalt mold. But one thing you must know is the mold that you use to start drilling is called spud mold. From our introduction, it says that simple mold systems are converted to complex mold systems as the well deepens. And as temperature increases, pressure increases, the geological formation differs. So as you start with your spud mold, as you start drilling deep, it may become low solid mold, depending on the area you're drilling. It may become lignite mold, depending on the area you're drilling, Nigeria or other parts of the country. It may become lignite surfactant mold. It may become lignosulfonate mold. It may become lignite lignosulfonate mold system, depending on the area you are drilling. In the Middle East, it may be lignite. In other parts of Africa, it may be low solid mud. It may be lignosulfonate mud. So from spud mud, you start the drilling and continue and make it finer or more complex. Then we have inhibited mud. Remember, I told you that inhibited mud, they remove water from the formation. They make the clay, the shell not to react with water, because your mud that you're using to drill is water. And when water and clay meet together, definitely clay will absorb water and the clay will swell. The clay will swell. When it swells, there is no way you can drill. Your pipe cannot continue to go up and down. Your bit cannot continue to drill. The clay will hold it. So inhibited mud is that mud which represses the hydration. It represses the hydration. It prevents the hydration and subsequently dispersion of clay into the mud. It will not allow the clay to take water. It will react with it in such a way that the clay will be removed. Now there's what we call clay chemistry. As you go on, you understand there's another course on clay chemistry. Clay is basically silicon with some derivatives. But the clay that swells is sodium silicon. It has sodium to it. So inhibited mud systems have chemicals like potassium chloride that will react with the clay and displace the sodium in ionic exchange. It will just remove the sodium from the silicon. And that clay, because there's no more sodium, it will not be able to absorb water and it will not swell. And as they cut it, as the bit cuts it, the mud will just carry the clay inside the mud, bring it out. Your solids control system will remove them. So in inhibited mud systems, we have lime mud. Lime mud, because of the pH of lime is very high. We have low lime mud. We have gypsum mud. Gypsum is another type of clay or another type of bentonite that is very, very reactive. We have seawater mud. Seawater mud, mud that we prepare with seawater. Mud that we prepare with seawater. We also have salt-saturated water mud. Salt-saturated water mud is mainly used in salt formation. You're drilling through salt formation. Remember, for you to be able to drill through that salt formation, the salt in your mud will be greater than the salt in your formation in liquid phase, so that you will be able to drill there. We have the potassium plus mud. These are trade names. We put K stands for potassium. Potassium plus mud. Potassium chloride or potassium is another type of mud that helps. The potassium, like I explained earlier, can displace sodium with respect to the chemical chemical series. Potassium will displace sodium since it is higher. And once the sodium goes away from the clay cannot absorb water. And once it cannot absorb water, it will not swell. Thereby, your hole will be in good condition. We have the KCl, that's potassium chloride glycol mud. It's water-based mud. KCl is there to do inhibition. Glycol is there to give another enhanced inhibition. If you're drilling through a cold region, glycol has a heating effect, hot effect. It will withstand the cold area. It will prevent the mud from freezing, from becoming block, from forming hydrates because of the heat effect of glycol. Glycol can also give you lubricity in your mud. So these are a list of inhibited mud system. We talked about freshwater mud, freshwater-based mud, and now inhibited mud system. And remember, for some of this inhibited mud system, you start with fresh water. For example, the lime mud, you start with fresh water and you put your lime amongst other things. But the basic components of mud is the same. There must be a viscosifier. There must be something that gives you weight. The basic component, it must remove cuttings. It must give you pressure control, well stability. So these mods are helping to also give hole stability like that. To give hole stability. Inhibited mud systems still containing advantages of inhibited mud system over conventional water-based system. Will tolerate a higher concentration of clay before developing high viscosity. If you just have water and a viscosifier, let's say bentonite, we are saying that this inhibited mud system, they can tolerate a higher percentage of clay before they begin to have problems. They can tolerate a high concentration of clay, or they can tolerate a higher concentration of solids before the viscosity becomes too high and cause problem. Inhibited mods are less drastic effects by contaminants such as cement and hydrides. Thus, contaminants do not affect them so badly like water-based, freshwater mud. When contaminants enter, because you already have some things in your mud to handle these things, it doesn't cause too much problem. When we talk about cement, drilling, you may be drilling through limestone. Limestone is same thing as cement. Limestone, how does it affect your mud? And hydrides, calcium hydrides. When they enter your mud, your inhibited mud system will handle it. Take, for instance, the lime mud. When you have hydrides, calcium oxide, and the rest enter your mud, the lime will react with it, and you have a precipitation and water and calcium carbonate. The water will just be there. The calcium carbonate will come out as a precipitate, and it's out because you already have your lime. Remember, when you are choosing a mud system, you're also thinking about the type of contaminations, the type of geological formations or lithology you have that you're going to drill through. Inhibited mud systems can be raised to a higher mud weight before developing excessive viscosity. You can raise them to higher mud weight, but ordinary freshwater mud, as you're increasing the mud weight, before you know, the viscosity is increasing and the pump will not be able to pump it. But inhibited mud systems, as you're adding your weighting material, for example, barite, barium sulfate, as you're adding it, it will be able to accommodate it and give you the weight you want. But freshwater mud, as you're increasing the weight, it's beginning to have problems. The mud pumps are beginning to cry, oh, the sand is, the solids inside are too much, and it will not carry out your cuttings from the well properly. But inhibited mud systems, they can accommodate. They will still be looking like fluid. They will still be, you still see them as fluid, functioning very well. Number 4, less progressive gelling tendency. Inhibited mud system, when we talk about less progressive gelling tendency, remember your mud is thixotropic. Thixotropic in the sense that when you agitate it or apply pressure or stir it, it becomes liquid. In dynamic condition, it is liquid when it is circulating. But when it is not more circulating, it becomes gel. Now, when we say less progressive gelling tendency, when a mud forms gel and the gel is so strong, it's progressive. We mean that the gel is too high. But in the case of inhibited mud systems, the gelling is not very strong, it's not very high, such that it can easily be broken by the mud pump when you want to start circulating again. Water-based emulsion mud is that mud with oil and water being emulsified together. Remember, I said water-based emulsion mud has some oil in it, not so much. The continuous phase or the base fluid is water, and you have oil inside. The oil and water does not mix, but because of the other chemicals you have inside, it enables the oil and water to mix. Because of the other additives, let me use the correct word, additives, or mud chemical additives. The oil is being mixed in the water. The oil is dispersed in water because the water is more than the oil. Advantages of this type of mud, water-based emulsion mud. Mud where you have, it is water-based, but you have some oil inside. One, the advantage, it reduces pipe tug and drag. Pipe tug. By tug, we mean, the pipe is rotating. As it's rotating, there is a particular pressure that the rig, the driller uses in turning it. When he uses that particular pressure and it is not giving him what he wants, for example, he applies like 7 kips. 7 kips means 7 kilopounds. 7 kilopounds or 7,000 pounds. If you apply 7,000 pounds to be rotating the pipe will be rotating, and maybe it gets 60 RPM, 60 rotation per minute. When we talk about tug and drag increasing, as it's rotating with particular 7,000 kips and is getting 60 RPM. When he still applies that to maintain that 60 RPM, it's now applying up to 8,000 pounds or 8 kips. It means that you are beginning to have torque. Torque means you are finding it difficult to rotate the pipe. So emotion mode reduces pipe torque and drag. Drag we talk about when you're pulling the pipe up and down. You have to pull the pipe up and down to ensure that your pipe is free, to ensure that your pipe can continue drilling. You can continue drilling, to ensure that your hole is clean, is free. When the weight, you know the pipe weight, you know the drill bit weight, you know the fluid, with respect to the viscosity, resistance to pipe and everything, you know the amount of pressure you apply to pull this pipe. When you're exerting more force to pull it, that is what we call drag. It means that there are some things in your well or your mud that is not permitting the driller to pull the pipe as easy as it's supposed to. Increases ROP and bit life. This water-based mud that have some oil in it, water-based emulsion mud, it increases ROP. When we talk about ROP, it's rate of penetration. Rate of penetration, the rate at which you're drilling. Yesterday, I talked about you could be drilling at 20 meters per hour. Your ROP is 20. It increases. The driller can even go more than 20 because the mud is good for him. And beat life. You know, the beat, as the beat is grinding, the teeth will be getting dull, just like you use a knife continuously. As you're using a knife for all manner of cuttings, at some point in time, the knife edge will begin to look dull. The bead too, as you're using it, beads are expensive, eh? Very expensive tools. As you're using it, it's hydraulic. As you're using it, grinding and grinding, limestone, rock, and every other. And take note, the formation downhole, as you go down, the formation is more consolidated, it is more compact, it is more hard than it is in surface. So as the bead is doing its work, there is wear and tear, like we have it in our vehicles. The bead teeth are becoming dull. But with water-based emulsion mud, the bead life is extended. It helps preserve the bead's life. Oil-based and synthetic mud. Oil-based and synthetic mud is that mud with oil as its continuous phase, with not more than 1 to 5% water. With not more than 1 to 5% water, depending on the area you are drilling. In Nigeria, because of how good our formation is, sometimes the percentage of water even increases to 20, 30, like that or more. So the continuous phase or the base fluid is oil. The dispersed phase is water. In emulsion mode, you have water. Water-based emulsion mode, you have water and oil dispersed inside because your base fluid is oil. I mean, water is more. But in oil-based and synthetic mode, your base fluid or your continuous phase is the oil. You have little water, so the water will be dispersed in the oil. Remember, water and oil does not mix. But of course, it is the duty of the mud engineer to make it mix because of the additives. There are additives you're going to add, like emulsifiers, that you're going to add, that they are polar and non-polar. They have one polar end and non-polar end. The polar end will hold water, the non-polar end will hold the oil, and it will mix. Just like when you have two enemies and you're a friend to both of them. Because you're a friend to both of them, you can make the two of them become friends. You use one hand and hold the other one, and you use the other hand and hold the other one, and you make them communicate together. Because of you, they become friends. So we have things like emulsifiers that are mud additives that will make water and oil mix. Advantages of this type of mud, very good. This mud is very good, very stable. The advantages of oil-based mud, oil-based and synthetic-based mud. It's protection of production zone. Protection of production horizon or production zone. It protects the area you're drilling, the area you want your oil, gongo. The oil, they call it juice. Some people call it the juice. Some people call it show. They have all different names for it. They call it the pay zone. Pay zone, where you have what you're looking for. So it protects the production zone. Drill water sensitive formations such as salt, clay. You can use this mud as it is to drill water sensitive formations. Remember, if you carry water-based mud to go to water sensitive formations like salt and clay, it will just melt the clay, the salt, and that formation will not be. Imagine you have a block and you carry water, you want to form a hole, and it is water you're using to form that same hole. The hole will not be very stable. Or you see clay and you want to drill a cylindrical stuff through the clay and you're using water, it will not give you that cylindrical shape inside. But in the case of oil-based mud and synthetic mud, because oil does not react with water, you can use it to drill these clay-sensitive, salt-sensitive formations. Very sensitive formations, you can use it to drill. It allows longer beach runs than water-based mud of the same weight. It allowing longer beach runs. What we mean by longer beach runs means you can use the beach for a longer time when you're using oil-based mud. Remember, oil gives you some lubricity. Oil is slick. It can lubricate. It's oil we use in lubricating things. So the abrasion is reduced. The contact with the formation causing abrasion and the rest, because of the oil there, is reduced. Now, when they talk about same weight means assuming you are running a 10 ppg mud, 10 pounds per gallon ppg, 10 pounds per gallon mud, or 1.2 sg mud. The beach you're going to use in the oil-based mud will last longer than that of the water-based mud. That's what we are saying. Less viscosity problem in deep hot holes. Less viscosity problem in deep hot holes. Oil-based muds are more resistant to high temperature. The viscosity, you won't have problem with viscosity when you're drilling hot or high temperature zones. All you need to do is to get temperature resistant chemicals which are available to drill that section. So these are the advantages of oil-based mud over water-based mud system. WBMs. The following designations are normally used to classify water-based muds, drilling fluids. Now, when you hear this type of, we're just calling some different types of water-based muds. There are many. There are many, a lot. You hear non-dispersed, non-inhibited systems, spud muds, polymer, bentonite mud, extended bentonite mud. Bentonite is a viscosifier. It's a clay, natural product, not synthesized. It is like clay, but special clay. It is one of the fundamental chemicals, additives for mixing water-based mud. In most water-based mud, it is used. In some water-based mud, it is used more than other water-based muds. So, first of all, we have non-dispersed, non-inhibited systems. Those ones are very simple mud systems. If you look among the list, you see spud muds. Like I said, spud muds are mud that you use to start drilling. From spud mud, you go to polymer bentonite system. You go to extended bentonite mud, where you add more other chemicals to it. Then you have the non-dispersed inhibited. Take note, the first one is non-dispersed, non-inhibited. Non-inhibited in the sense that we don't have chemicals that will take care of the clay, that will remove the sodium ion, that will make the clay not to react. Then we have non-dispersed inhibited system. We have salt mud. When we talk about salt mud, as in the salt, you know, sodium chloride. We have the KCl polymer mud system. Then we have dispersed, non-inhibited system. We have lignite, lignosulfonate mud. We have phosphate bentonite muds. Then we have dispersed and inhibited systems. Mud, we call it system. It's a system because it runs. It does all manner of functions. That's why we call it system. It's made up of different components, both liquid, solid, and the rest. So when you see system, it's mud. What kind of system are you using? There are different types. And different types, they have specific functions why they are using them, with respect to your geological or lithology formation, and with respect to the reasons why you're using them. Non-dispersed, non-inhibited systems or fluids. The non-inhibited, non-dispersed fluids do not contain inhibiting ions such as fluoride, calcium, potassium. In the continuous phase, they don't have it. That means they don't have it in the water. Non-inhibited, non-dispersed, they don't have all these salts, this salt, potassium, things you will use to take care of the formation. They don't have it. They don't have it in the continuous phase. The continuous phase is water, and do not utilize chemical thinners or dispersants to affect fluid control. When we talk about chemical thinners, if your mud is too viscous, you put a thinner. Thinner as in the kind of the same word thinner you use in paint. Your mud is too thick. You want to make it light. You are thinning the mud. That is the terminology. So we don't have thinner to make the viscosity less, a little to be reduced. We don't have those things in the mud. Non-dispersed inhibited fluids do not contain inhibiting ions, but do not utilize chemical thinners or dispersants. Dispersed inhibited fluid systems utilize chemical thinners or dispersants. You see things like the lignite in this particular area, but do not contain inhibiting ion. Dispersed, inhibited. Now, when we talk about dispersed, means they have thinners or dispersants, they have thinners. When we talk about inhibited, means they have salt that will take care of the formation. When we say they are dispersed, they can help reduce viscosity because of the type of formation we are drilling. The type of formation we are drilling can easily cause your mud viscosity to increase. Because of that, you have something in your mud to constantly be reducing the viscosity. Inhibited means you have something in your mud that can take care of the water effect on the clay or on your formation. When referring to a water-based mud system, the term non-dispersed means that clay is free to find its way, find its own hydrous dispersed equilibrium in the aqueous solution. It is not dispersed. The clay can do anyhow it likes. It can continue as it goes. The term non-inhibited refers to the lack of specific ions, such as potassium, calcium, and chloride that will inhibit the ability of the formation to absorb water, just like I've explained. Spud mods. In the next 3 slides, I will take a break for question and answering. Spud mods. Spud mods are used during drilling. 1, to clean the hole. I want us to take note. To clean the hole, prevent sludging of the surface hole. Prevent sludging of the surface hole. Provide a viscosity sweep to clean gravel, sand from the borehole, and then form a filter cake to prevent seepage to the formation. Seepage is the same thing as losses, but seepage is a reduced form of losses. Losses, your mud will just be entering your formation. Seepage, your mud will be going, but you can control it. But when it is losses, you can control it, but it will give you some stress. You have to do something very drastic about it. So spud mud is used to clean the hole. If you check number 3, it says to provide viscosity sweep to clean gravel and sand. All this gravel and sand, you see them at the surface interval. When you're starting your drilling, you see them, big stones, because you're still where the formation is not well consolidated. Formulation of spud mud. What are the formulation? Now, when we talk about formulation, means how do we combine the chemicals? What chemicals do we bring together to mix this mud? What chemicals do we bring together? And in what concentration? What amount? If we have 1 barrel of water, what amount of what? If we want to mix 1 barrel of mud, or want to mix 100 barrels of mud, what amount of water are we going to bring? What amount of salt, bentonite, or other chemicals are we going to bring? What is the ratio? What is the concentration? That is what we mean by formulation. For every spud mud, like we say, spud mud is a water-based mud. First, you have water. Your water could be fresh water, could be brackish water, it could be salt water. Then you have your caustic. Caustic, 8.5 to 10.5 pH in fresh water. Caustic gives you the pH. Caustic gives you the pH to enable your mud, some of your mud chemicals to function very well. For example, if your pH is too high, your bentonite will not work well. Some of your polymers will not work well. So your pH has to be right. If your pH is also too high, the hydroxy ions are too high, it means that it can also affect the equipment. If your pH is too low, some of the chemicals will not work well. And it will be acidic. It will affect rig equipment. So caustic gives you the pH. Caustic is part of the things you use. First, we say water, caustic to give you pH, 8.5 to 10.5 pH in freshwater mud, 10.5 to 11.5 pH in saltwater mud. Now, this system is a global system. In Nigeria, we hardly run pH up to 11. We hardly run pH in our water-based mud up to 11. Hardly do we do that because of our type of formation. You see our pH will be running between 9.5 to 10.5, sometimes 9 to 10, like that. But in some other areas, you see that the pH will run even up to 10.5, 11, 11.5. So we are giving you a global standard. You may be in the rig and you see the mud specification, say pH 9 to 10.5, pH 9 to 10, you're in line. The next thing for spud mud is clay, 10 to 30 pounds per barrel. Now, 30 pounds per barrel is a form of concentration. What amount of clay are we putting in one barrel? 30 pounds, 10 pounds, depending on the kind of formation you're going to drill and depending on the geological formation, the area. If you're drilling in the Middle East, if you're drilling in America, Africa, what amount of clay are you going to put in one barrel of mud? You want to mix one barrel. Here, it tells us that we should put 10 to 35 pounds per barrel, depending on the mud weight. Freshwater mud, sodium bentonite mud. Now, this clay is sodium. If you watch, it writes water sodium bentonite, because sodium, even the bentonite is silica. The bentonite, I told us, is a kind of clay. Same type of clay you have in the formation, but this one, it's even better off. It gives you viscosity. It is finer. They've prepared it such that it is finer, so that when water touches it, this time around, you are the one preparing it. When water touches it, it gives you viscosity. Now, if you carry this same bentonite and you're taking it into your formation to also drill same clay, you see that you have problems, except you add more other things to it to handle the clay downhole. Saltwater attapogite or prehydrated bentonite. For fresh water, you can use bentonite, sodium bentonite. Sodium bentonite. If you want to mix spud mud for salt water, then you use attapogite or prehydrated bentonite. Prehydrated bentonite in the sense that you mix your bentonite in fresh water, then you get some salt water, add to it to increase the volume. Well, as time goes on, you understand this one better. Polymer bentonite mud. Polymer bentonite mud. Polymer bentonite systems are used primarily in areas where the formation to be drilled contains low reactive solids. Low reactive solids in the sense that the clay is not much, shale is not much. The clay may be there, but it does not react with water. When they say reactive, reactive means it does not react with water so drastically. Some clay, any little water, it's a problem. Let's take, for example, there are some areas in Nigeria, if rain falls, that place is in a mess. It's a mess. The clay is very, very reactive. Any small water, any small rain. But there are some areas too, rain will fall and there is clay there, but vehicles will still be passing. The water, the same amount of water on this clay is the same amount of water on that other clay. So when we say the clay is reactive, it means that water can make it swell anyhow. It will give viscosity. If it is downhole, if it is where they are drilling, it will cause problem there. It's very reactive. So polymer bentonite mud, we use it in areas formation where the formation drilled contains low reactive solid. The system can tolerate low concentration of calcium. water containing calcium in excess of 100 milligram per liter should be pre-treated with bicarbonate of soda to precipitate the calcium. What we are saying here is, if you have calcium contamination, sodium bicarbonate. When you see bicarbonate of soda, is sodium bicarbonate they are talking about. The IUPAC name is sodium bicarbonate. You can use sodium bicarbonate to treat your mud or your water that contains calcium. Your water you want to use in preparing the mud, it contains some hardness of calcium up to 100 milligram per liter or ppm. You can treat it so that your bentonite can work well. Formulation of this type of mud, of course, you have your water, whether it is fresh water, salt water, or water that contains little calcium, maybe less than 100 milligram, or even if it is more than 100 milligram, you can always treat the water with sodium, sodium bicarbonate, that's soda ash, to remove the calcium. Then the next thing is sodium bentonite. Now I want us to take note. If you watch here, the bentonite concentration, that's the clay, sodium bentonite, is 10 pounds per barrel. Look at in the case of spud mud, 10 to 35 pounds per barrel. Bentonite gives you viscosity. Polymers also gives you viscosity. So in this case, we are saying we want to reduce the bentonite. Remember, as you're drilling deeper, as the well deepens, goes deeper, your simple mud is being converted to a more complex mud. You start with bentonite, you start with spud mud, and now you're drilling more. You are adding more polymer to it. Your bentonite, you must make sure that your bentonite is less than 10 pounds per barrel. And now we have a lot of polymers we can add. We have CMC, carbon cellulose, carbon methyl cellulose. We have PAC, partially hydrolyzed cellulose. Low viscosity. These are low viscosity chemicals. When we talk about polymers, we are talking about starchy materials. They look starchy materials. The third one is corn or potato starch. They work on it, they purify it such that it becomes starch. It becomes even better than the starch we eat. It gives you more jelly, more viscosity than those ones, and they have their functions. Because it is jelly, it can give you filter cake, good filter cake. It can give you lubricity. So now, in most cases, as you're drilling, you start with your spud mud. As you're going down, you'll get to a particular point as with respect to the drilling program or the mud program, how they want the drilling to continue. When we drill to this particular depth, we'll be using spud mud. When we get to this place, because of the formation, we will be using polymer bentonite mud. So as a mud engineer, you begin to prepare yourself before you even get to that point where you begin to use bentonite, polymer bentonite or bentonite polymer mud. You begin to stop putting more bentonite. You reduce the amount of bentonite you put. You mix more mud. If you're mixing fresh mud, you go with this formulation. The one you have, you begin to add all these polymers to it. Remember, polymers, if you want to define it, are long chain carbons, are long chain chemicals. Long chain chemicals, they have long chain. They are long chain helps them to give you that viscosity, matting properties that helps to control fluid loss and other functions. Extended bentonite mods. Extended bentonite mod. Now this, your spot mod is a bentonite mod. The next one, you have polymer bentonite mod. And now we have extended bentonite mod. As you go deeper, or because of the kind of formation you have, you don't want to use oil mod, maybe because of environmental regulations, government regulations. But this bentonite mod, you know that it's not okay, but you want to make it in a way that you can still use it in areas where ordinary spot mod will not work. So you continue to add more things to it. Extended bentonite mod system contains chemicals that extend the yield of bentonite and impact the desired properties to the mod while maintaining minimum solids content. When they talk about maintaining minimum solids content, remember the solids are the things you're removing from the hole. So you must ensure that there are not much in your mod system, which in turn improve penetration rates. We want to look at the formulation for extended bentonite mods. Water. The water, you treat out calcium with soda ash. The same thing we've said before now. If your water has calcium, you treat it with soda ash. You can also add a caustic soda to give you the required pH. You had your bentonite, 10 to 15 pounds per barrel. You don't need too much clay because you're drilling through clay. Some of your formation will be clay, so you don't need much. You just need it to give you viscosity, to be able to carry your cuttings. Then you have other polymers. Polyacrylate is a kind of system of polymer. It says 0.04% by volume, 0.04% by volume. If the system is weighted, more is required. That's if the system is weighted. If you're running your mod weight of 9 ppg, 9 pounds per gallon, you can go with 0.4% by volume. But if you're going to 10 ppg, 11 ppg, you need to add more of the polyacrylates. They are polymers, and they also have very good fluid loss properties and inhibition properties. You have polyacrylamide, 0.5 to 3 pounds per barrel. 0.5 to 3 pounds per barrel. Depending on the application, there are many other chemicals that can be used to impact viscosity and filtration control, such as polyanionic cellulose. That's PAC, the one we saw earlier, PAC, P-A-C. Xanthan gum. Xanthan gum too is very good. It will give you viscosity. It will prevent fluid loss, seepage losses. Potato or corn starch, just they call it starch. It will also give you fluid loss. It will help you not to be losing fluid. It will also form filter cake for you so that you don't lose too much mud into the well. Please get ready. I will soon take a pause and we will discuss any area for clarification. Non-dispersed inhibited fluids. The system described below are classified as dispersed inhibited fluids. We're looking at non-dispersed inhibited. They're inhibited, means that they have salt. They have things that will take care of the swelling of the clay or the formation. Because prehydrated sodium bentonite finds its own equilibrium. Now, when they say it finds its own equilibrium, it will continue to take water. It will continue to take water until it gets to a point where it cannot swell again. Clay will continue to take water. Let's take Gary. There is a particular amount of water Gary can take. If you keep pouring water, it will be taken until at one point it becomes saturated with water. That's what we mean. Chemical dispersants, that's thinners, are not added to the system. Chemical dispersants are not added to the system, but they have salt that can handle the formation. Included in this system are certain mud containing salt ions, sodium chloride, potassium chloride, mainly for water-based. We are still talking about this water-based system that inhibits drilled formation. When we say inhibits, it prevents the formation from taking water and swelling. That's what we mean by inhibition. Inhibits formation solids from swelling and breaking into smaller particles as they are transported to the surface. This makes it easier for the solids control equipment to remove. Because they don't take water, we prevent them from taking water. As the bit drill them, they will come out like that. And that as they come out in lump, the solids control equipment can remove them. But if they swell and take water and wash themselves inside the mud, it is difficult to remove. So inhibited, non-dispersed inhibited fluid systems do not have thinners, but they have salt that inhibits the formation. Attapogite, starch, salt, mud. Attapogite, starch, salt, mud. Some of these systems are still in use, while some are not in use. In Nigeria, you may not come across them. But when you go to the Middle East, some areas in America, you will see them, especially land formations, land drilling operation. Salt muds are used to improve borehole stability through the inhibiting effect of the salt. The salts present in the makeup water to minimize hole washout. Hole washout here means that you are drilling a hole, the size of your hole is 16 inch in diameter. When you're drilling and it has washout, it means that it's not all the areas that will be washing out, some areas will be washed out. It means that some areas, the hole is more than 16 inch in diameter. Some areas it could be 16.5, some areas it could be 17, 18, it can go as bad as 19. That's what we mean by washout. Washout is the area that you did not drill, but has become part of the hole. Has become part of the whole diameter. And to prevent drill solids from disintegrating as they are transported to the surface. So they prevent hole washout and also prevent the cuttings from breaking down into smaller particles. Now, when we talk about breaking down into smaller particles, the breaking down could be into fine sand or fine clay particles that when you carry it, you will not see it, but it is there. You only know that it is there. You're seeing it as inside the mud. You see that your mud, the viscosity of your mud has increased more than normal. So you know that it is there. All right, the formulation for attapogite starch salt mud. Attapogite starch salt mud. Attapogite is a kind of bentonite that will give you viscosity in salt water. Sodium bentonite is the one that will give you viscosity in fresh water. Attapogite will give you viscosity in salt water. Attapogite is a particular kind of bentonite. The sodium bentonite is called Montmorillonite. Montmorillonite, the bentonite that gives you viscosity in water. It is called Montmorillonite. The type of bentonite or clay, you can call it clay, you can call it bentonite, but we call it bentonite for the case of for the purpose of our study. It's attapogite. It will give you viscosity in salt water. So the formation here is salt water or natural brine. Now, when we talk about salt water as in seawater. Natural brine means you buy your salt and you put your salt in water and mix it in a particular ratio, just to, assuming you are not drilling through swamp, you're not offshore, you're drilling on land. You want to mix and you want to do a tapu guide. Get your water, get some salt and put inside, it will give you brine. Brine means salt dissolved in water. That's what brine means. Then you have your caustic soda to give us pH by meter. When they say by meter, use pH meter to check your pH. You also have pH probe. You also have pH stick. You also have pH paper. Whichever is available, you can use at that point. Then here you have your tapu guide, which is your bentonite or your clay that you're going to use in mixing to give you viscosity. 10 to 20 pounds per barrel. Then you also have your polymers to also give you more viscosity and also add to help in controlling fluid loss. You have your cornstarch, 0.5 to 5 pounds per barrel. You have other polymers, 0.25 to 1.25 pounds per barrel of pack. That's polyionic cellulose. You have the CMC, you have the xanthan gum, you have the guar gum. All these are chemicals that gives you viscosifiers. They are polymers. A tapu guide does not contribute to filtration control. So these polymers are the ones that will give you filtration control. When they talk about filtration control, it will not allow your fluid, your mud to go into the formation. It will cause filter cake. So your polymers are the ones that give you the filter cake. The polymers or the starch, you use them, they give you viscosity, they give you the filter cake. Okay, at this point, I want to stop for 1 or 2 questions before we continue. You can unmute your mics and let's areas to clarify. Can I continue?
Sorry, sir. Please, under spot modes.
Yeah.
You said I used during drilling to clean holes and to prevent sloughing of the surface hole. Please, may I understand what you mean by sloughing of the surface hole?
Okay, now you know that take a shovel, start to dig a hole. As you're digging the hole, you see that the place you have dug, some of them want to fall inside the hole. Have you experienced something like that?
Yes.
Yeah, that is what we mean. So this spot mud, the major function is to clean the hole. You just want to clean the hole because that surface hole, spot mud is used for surface interval. And the surface interval is not consolidated, it's very porous. It can take water. Your mud loss is more there. Your mud will be entering. You have gravel, you have sand, you have clay. It's very unconsolidated. If you dig a hole and pour water, the water will just enter the hole, one hand. It will disperse, it will go in. And as it is going in, it will be swelling. Because this spot mud is very simple mud. Just clay, water, caustic, soda ash. So we use it to clean the hole. No matter what you do in that surface hole, because it is very porous, you must have losses. So your target is bring out all these things. The surface hole has gravels, big stones. As you're drilling, they will be coming out. They will be coming out. So your spud mud must have enough viscosity to be bringing out all these cuttings, gravel, stone. Whatever is being drilled. So that is what our spud mud is there to do. Is it okay?
Yes, sir.
Okay. All right. Can we take 5 minutes, then we come back and continue? So we will come back around, let's say, 1:45. Hello? Hello, Samuel. Hello, Vincent. Hello, are you there? Hello, Peter. Hello, Samuel. Hello, Vincent.
I'm right here, sir.
Okay,
I'm right
that's
here.
great.
Yes.
So we will continue. We are already past our normal scheduled time, but we'll continue. I'll try to see how we won't be too much far away from our time. We're talking about saturated salt mud. Right now, we are beginning to see the formulations are all towards the same direction. When they say saturated salt mud, the major thing there is the salt. Saturated salt water is the salt. You just get your salt water and you mix your attapulgite. Because it is salt water, it is attapulgite you will use. Since attapulgite is the one that gives viscosity in salt water, then you have your polymers in their little concentrations. Potassium chloride polymer mud. When they talk about potassium chloride polymer mud, these are inhibited mud systems. They are water-based mud systems. All they are telling you is that it has potassium chloride that is used to inhibit the clay from swelling. It inhibits the clay from swelling. The K ion is the one that does this work. The K ion will displace the sodium ion in the formation clay and make it inactive. So you see the potassium water is there. Sometimes you can mix your mud and then have your potassium. Now, if you see this place potassium water and you see caustic soda for pH, you see prehydrated bentonite, that's bentonite or attapulgite that you mix already. You have already mixed it. When they mean prehydrated, it means that you have mixed it with water. Prehydrated, you have mixed it with water. You have gotten the normal volume you want. Then you have your polymers. So you see, basically, you have water, you have bentonites, viscosifiers, and you have polymers. And then the other things you had in water-based mods to take care of so many things, but these are the basic things you had in this type of mud. Lime mud, fresh water or salty water, sodium bentonite, not more than 15 pounds per barrel, caustic, lignite, lime, lignosulfonate, starch or polymers. So you see here, the concentration is on lignite, lime, lignosulfonate. So the basic formulation is there: water, bentonite, sodium bentonite, or attapulgite. I told you sodium bentonite is montmorillonite, while the salt bentonite is attapulgite. So you see fresh water, bentonite, or clay, caustic, polymers. Then these ones, lignite, lime, and lignosulfonate are the ones representing the lime mud. Then you have seawater prehydrated bentonite. Seawater prehydrated bentonite. Seawater prehydrated bentonite. Now, when they say seawater, it means that you are using seawater and then you are prehydrating bentonite. This prehydrated bentonite means that you mix your bentonite in fresh water. And as you mix it in fresh water, you mix it in high quantity. Check the concentration. Number 3, sodium bentonite, 30 to 50 pounds per barrel. You mix your bentonite first, then you get the volume of bentonite. Let's assume you want to mix 2,000 barrels of mud. You will mix 1,000 barrels of bentonite and then get 1,000 barrels of salt water, and you put them together. This 30 pounds per barrel will become 15 pounds per barrel. This 50 pounds per barrel will become 25 pounds per barrel because volume has increased. Like I said, there's a seawater. If you remove the seawater, you just see rehydrated bentonite mud. But because you have seawater is included. This kind of things is done at offshore where you don't have the luxury of water. You don't have all the water in place. So you do it like that. You try to make use of your seawater from the ocean or from the sea or from the river. KCl, PHPA mud. KCl, PHPA mud. Every other thing is the same, except that this time around, you are adding KCl. What's the work of the KCl? It will inhibit deformation. What's the work of the PHPA? PHPA is a kind of polymer. It also has inhibition properties, and it also minimizes the hydration of clay. It encapsulates. It's a polymer. Once the cuttings, the drill bit has drilled the cuttings, the PHPA, what it does, since it's a polymer, it will just capture the cuttings. It will capture the cuttings and bring it out to the surface. PHPA is used for encapsulation. It will capture the cuttings in small bits, and when it comes to the surface, the shakers will shake them off, the cuttings will go out, the PHPA will still come in. PHPA could be in powder form or liquid form. So you have your mud system, but in this case, you have KCl and PHPA. KCl could be in 3.5 pounds per barrel, 3.5 to 5% by weight or by volume, but mainly is by weight. So if your mud is 9 ppg, 9 pounds per barrel, out of the weight, your barite, 3.5% will be KCl. So in your formulation, you will calculate all this stuff. When your mod program comes, your mod program will give you the yardstick to give all the calculation. PHPA, so KCl, PHPA, glycol mod. Like I said, the only thing here is now you're adding glycol to it. Remember, your mod systems is moving from simple to more complex system. Like I explained yesterday, drilling has become more complex. When drilling started, it was just simple mud, and the hole they drill is very, very shallow. They will drill 500 meters, oil is coming out. 1,000 meters, oil is coming out. 200 feet, oil is coming out in some places. But now, drilling has been, they've been exploring and producing such that they need to go deeper. And the deeper you go, the more care you need to take, the more complex, the more challenges that are there. Okay, glycol is used for lubricity, stability, prevents clouding. It prevents clouding, that it will prevent hydrates. It will prevent your mud from freezing, especially in cold regions. Regions where the temperature is very low, like the North Sea. In the US, in Canada, those places where you have extreme cold weather, glycol will be of great help in those areas. Silicate mud, same. It provides inhibition and holds stability as soluble silicate precipitate to form an insoluble silicate film in the hole to prevent water contact with shale. All it does is inhibition, different types of inhibition. And in this case, the mud can be used at pH more than 11. You're not crying for pH. The silicate will still work well. Every other thing will still go on well, even if your pH is very high. Polyamine high performance water-based mud. Anywhere you see HP, it means high performance water-based mud. Polyamines are used in high performance water-based mud for the ability to stabilize clay when drilling through water-sensitive shales. Now, in some countries, they have environmental law. You cannot use oil-based. You cannot use synthetic. If you're going to drill, it must be water-based. So in those kind of countries, you use high-performance water-based mud. You see them, you will use glycol, they will use KCl, they will use PHPA, and they will also use polyamines, where they are drilling through shales, clays. These clays are very stubborn, and they are going deeper and deeper. The deeper you go, the more problematic the water reactive clays are. So, of course, chemicals that will handle them will also be provided. So, polyamines, high performance water-based mud are used in these respects. Oil-based drilling fluids. The most common base oil used has been diesel and kerosene in time past. Diesel and kerosene. Diesel is still being used. They have an acceptable viscosity, low flammability, and low solvency for any rubber in drilling system. Diesel, however, is relatively toxic, making environmental impact of diesel-based mud generally higher than those of water-based. You'll discover that when they want to start using oil-based mud, they don't use it in surface holes. They use it intermediate hole and in the production zone because they don't want to have environmental impact. Remember, once you start drilling in surface hole, your mud begins to enter the formation. You don't know where it will come out. You don't know where it will come out and begin to kill all vegetation and animals. But in the case of water-based, as it enters the formation, if it comes up, it will evaporate. The chemicals you use in water-based mud, some of them, they are not so toxic. Even so, some in high concentration may be toxic. Mineral oils have replaced diesel oil and kerosene in environmentally sensitive areas of the world. Mineral oil contains much smaller percentage of aromatics than diesel or kerosene, and thus are less toxic to marine life. There's a wide range in aromatic content in mineral oils marketed today. Crude oil can be used in oil muds. However, it has some drawbacks. For example, crude oil has a significant fraction of light ends and does exhibit low flash points. Crude oil may be withered prior to use, may need to be withered prior to use. Also, crude oil often contains significant amount of aspartame that may present problems during drilling and completion and may affect the performance of invert emulsion additives. Now, for crude oil, sometimes they might want to use crude oil, but crude oil has gas. If you use crude oil, when they are trying to get information from the well, they'll begin to see small derivatives of gas, and they will think it's from the formation. Meanwhile, it is from what you're using. Environmentally, it affects. The flash point, when they mean by flash point and fire point of crude oil, is very low. Any small heat will make crude oil to catch fire. So that is the setback of crude oil. So you see that mineral oils are more better used. Currently, mineral oils are being used all over the world, though in some countries, they still use diesel. Oil-based mud, they are more stable. Water present in oil mud in the form of an emulsion. Water present in oil mud is in the form of emulsion. Like I explained earlier, the oil is more and the water is less. As such, the water is dispersed in the oil. The oil encapsulates the water. Maybe 4 oil particles to 1 particle of water, something like that. A chemical called emulsifier must be added to prevent the oil droplets from coalescing and settling out. That's emulsifier. You know, I explained earlier, emulsifier must be added. Emulsifier is a chemical with a polar end and a non-polar end. The polar end of the emulsifier will connect itself to water, while the non-polar end of the emulsifier will connect itself to the oil, thus bringing oil and water together. Even if you don't do anything, the water will not separate from the oil. A chemical with ability reversal agent is added to make the solids in a mud preferably wet by oil rather than water. Otherwise, the solids will be absorbed by the water droplet and cause high viscosity. What we are saying is, if you know it's oil-based mud, most of the chemicals we use reacts with water. But in this case, we have oil, more oil than water. The oil percentage, the oil fraction, is not able to handle all the solids you're going to put. As such, we have what we call wetting agent. We put wetting agent so that the solid particles we put, the solid chemicals we put, will be able to stay in the mud, such as barite. Barite does not mix with water. I mean, oil. Calcium carbonate does not mix with oil. Most of the chemicals do not mix with oil, but we have to bring this wetting agent to make these chemicals mix with water and oil. The emulsified water of an oil tends to increase the viscosity of the mud in a manner as inert solids. In oil-based mud, if you put water, you are finished mixing it. You are finished mixing it. Your mud is ready. If you add water to it, it will be as though you're adding solids to it. That's how it behaves. Well, when you go to mud testing, you will, mud contamination, you will see what we are talking about. This diagram may not be very clear, but we have 2 beakers showing water-based mud and oil-based mud. This looks like the color. The colors may vary depending on the additives we put. In some places, the barite you have, that's the wetting material, may be darker, it may be lighter. In some cases, the aspartame, these fluid control chemicals you add may be darker, it may be lighter. But if you mix from the start a simple water-based mud and a simple oil-based mud, this is what it looks like. Viscosifiers and thinners. Viscosifiers and thinners. Now, what is drilling fluid? Drilling fluid is that fluid that is pumped around during drilling. Drilling fluid, it's a fluid that is used during drilling for cuttings removal. What's the property that it uses for cutting removal? Viscosity. So your drilling fluid must have viscosity. It is that fluid that is pumped during drilling for pressure control. What is the property that handles that? Mud weight. It is also the fluid that gives you well stability. What is that gives you well stability? The starch and the polymers. So we want to look at some drilling fluid additives. Number 1, viscosifiers. We have common viscosifiers. We have bentonite for water-based mud. We have bentonite. Bentonite viscosifiers to enable the mud or the drilling fluids to carry cuttings from the bottom of the well to the surface. We have guar. Guar is a kind of clay that can give you viscosity in salt water and also in fresh water. But the viscosity of guar is short-lived. 5 hours, you mix guar. After 5 or 6 hours, it will turn to water. You won't have it again. So when you mix guar, you use it immediately. Starch is also a viscosifier used in drilling fluid. Starch as in starch, as in starch. But this time around, it is well refined such that the starchy properties are more than the one we eat. CMC, egg. CMC can be used in salt water. CMC is carboxyl methylcellulose. Carboxyl methylcellulose. It's an organic name, carboxyl methylcellulose. It can work in salt water. It can also work in fresh water. Egg. Hydroxyl ethyl-cellulose. Hydroxyl ethyl-cellulose. Egg is a viscosifier used in salt water, in brine. If you have brine or salt water and you mix egg, it will work. Bentonite, remember bentonite can work in, you have two types of bentonite. The multimodulonite or the sodium bentonite will give you viscosity in fresh water, while the attapogite will give you viscosity in salt water. Then you have the xanthan gum. Xanthan gum is very good. It's a polymer. From starch downward are polymers. Starch, CMC, EC, HEC, PHPA, partially hydrolyzed polyacrylamide. PHPA is partially hydrolyzed polyacrylamide. Xanthan gum is very good. In fact, it's a polymer. Fresh water, salt water, it will give it to you. It gives you viscosity. It gives you fluid loss control. Thinners. Now thinners, you see water and in bracket you see oil. If you're running a water-based mud, thinner is water. Your mud is too thick, you're too viscous, add water to it. But as you're adding water to it, other properties will be going down, like the mud weight will be going down, the KCl content will be going down, so you have to take care of those ones. If it is oil-based mud, oil is a thinner. You use oil, it will be thin the mud, though you will need to add some good quantity. Also, lignosulfonate and polyacrylamide. It's also thinner for water-based mud. Phosphate are also thinners. Deflocculants are also thinners for water-based mud and also for oil-based mud. First of all, viscosifiers, we have looked at it, and we have looked at thinners. If your mud is too thick, thin it. What do you use in thinning it? You can put water, you can put oil, depending on the type of mud, and you can also put a chemical that will chemically break down the polymer chains that gives viscosity. Weighting materials, pressure control. What do you use for pressure control? What do you use to give the mud, the hydrostatic, is weighting materials. We want to look at some weighting materials. Number one, limestone, calcium carbonate. The SG is 2.7. Dolomite, calcium magnesium carbonate. Siderite, iron carbonate. Barite, barium sulfate, sulfate, yeah. Micromax, magnesium oxide. Magnesium 6 oxide. Hematite iron oxide. But in this particular one, most of the ones that are being used are limestone, calcium carbonate, barite, and hematite. More frequently, barite and calcium carbonate, limestone. Their SGs are as follows. We also have KCl. KCl can be used for weight up, especially when you're doing completions when you're using brine alone. Sodium chloride too can do the same thing. Sodium carbonate hydroxide can also give you. Calcium chloride is frequently used. Sodium bromide is being used. Calcium bromide is being used. Potassium carbonate is also being used. Some of them are in liquid form. Some of them are in solid form. Calcium bromide can be in liquid form. It can also be in solid form, depending on how the operator wants it. Now, we've looked at viscosifiers, we've looked at thinners, and we've looked at weighting materials. Viscosifiers will carry your cuttings remover. Barite pressure control gives you hydrostatic and gives you weight. It controls the formation pressure. Thinners, if your viscosity is too high, you control it. What will increase your viscosity? Those same cuttings, those solids that you're removing from the formation. Some of them are clay. They are the ones that will increase your viscosity. So when you find yourself as a mud engineer in that situation, you will use thinners. And the easiest thinner you can use is water for water-based, oil for oil-based. Other mud chemicals or additives, inhibitors, shale inhibitors. These are inhibitors, the ones that will prevent your shale or your clay from reacting with water and swelling and causing problem for you. Number one, KCl. KCl uses ionic exchange. Glycol. Glycol has a kind of heating effect, hot effect, and it has inhibiting properties. Polyacrylamide, polyamine too are there. Then you have sulfonated asphalt. Sulfonated asphalt too are shale inhibitors. They will prevent your shale or your clay from swelling and causing problem for you. Hole stability, these ones are under hole stability, well stability. Then we have other additives, mud chemical additives, low circulation materials. When you are drilling and your mud is entering your formation, you will add these things so that your mud will stop entering the formation, or you will control it so that it will stop entering the formation. Size calcium carbonate. Calcium carbonate, we mentioned calcium carbonate as being used for weighting material. You can also use it to treat lost circulation. Look at the word, size calcium carbonate. You have powder calcium carbonate, and you have size calcium carbonate. When we mean by size calcium carbonate, the grains are in different sizes. They are small, but they're in different sizes. Resilient graphite carbonate. Now, graphite, it's a form of carbon, amorphous carbon, another form of carbon. It can also be used for lost circulation. Graphite also will give you lubricity in your mud. Particulates, that's particles. Walnut hulls. You know walnuts. That walnut, the walnut, they will grind it into specific particles, size, and use it. It will seal up, it will help prevent. It is grain, so it will block the formation pores. Where the mud is going, it will just, as you pump it, it's inside the mud, it will just go and plug it and stay there. It will not go away again. It will just stay there while the mud will come out. Vegetable fiber, grind peanuts. Vegetable grind peanuts. Peanut is granite. Granite shells. They grind it. When they grind it into powder form or to a particular size, it will solve the problem. Cellulose fiber like some vegetables, fibers, maybe wood. Wood is cellulose. Go to plank shade, all those sawdust, they will grind it bring it to a particular size and use it. Efron, microbubbles. Those are trade names. Microbubbles are trade names. Mixed metal oxide, tiny, tiny ones. When they say metal oxide, metal that has already corroded, they are corroded, they are waste. They can get them together, grind them into powder or sizable forms and use them as low circulation materials. We're still looking at other chemicals. We have corrosion inhibitors. Remember, your mud is water. If your mud is water, the possibility that it will corrode the equipment are there, especially in completions. Now, let me explain what completion is. Completion is you have finished drilling, you have run casing, you have cemented. Now you want to bring out the oil. That is completion. You want to carry out some rig operations or activities so that the oil will start coming out. As from down to surface, you put your pipes, everything. You want to start bringing the oil, producing the oil, the juice, or whatever name we call it, the gold. You want to start bringing it out, the pay zone. That is completion. So during completion, they mostly use brine, just salt and water. Salt and water will corrode your metals. So you use metal corrosion inhibitors. You put them inside. You have lubricants. During the water-based mud, you put some lubricants to make, when the pipe touches the casing or touches the open hole, it will not just stick there. The lubricant will make it still continue. Remember, the pipe is rotating and it's going up and down. The lubricant in the mud that you put will make it slippery, going in and out. Defoamer. Sometimes when your mud is flowing, imagine that you have so many chemicals and your mud is flowing, blah, 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 blah. The possibility of foaming is there. You have defoamer. When your mud is foaming, your mud weight is lighter. Foam has air. Foam is air entrapped by water. Air trapped by water because of some surfactants. So you have defoamer, it will break that bubble chains. And just like you had oil to, when you're washing a bitter leaf, I'm sure you must have experienced it or seen it. The foam is too much, you had a little oil, 2 drops. The foam will just gentle, they will just gentle. And you continue to do what you want to do. It is the same thing in the drilling. Oil mud concentrate, oil mud concentrate. Oil mud concentrate means you have some oil mud that it's the quality is very good. You can decide to put it in your WBM to give you a particular effect that you need, or put it in your OBM. Bactericide. Bactericide, some of these polymers, they are biodegradable. Starch, if you keep starch in your house, in the next 2-3 days, bacteria will start smelling. It is the same thing. So in order not for them to degrade microbially, to degrade due to bacterial effect, you put bactericide to kill the bacteria, prevent bacteria from acting on them. Oxygen scavengers. Oxygen scavengers. Now, oxygen scavengers are chemicals that will react with the oxygen. It will remove oxygen from your system, especially in your brine. For corrosion to take place, oxygen must be present, especially in completions when you're using your brine. Imagine you're using brine, salt and water. The salt itself can corrode. Remember, you put some salt in your WBM too. Salt can corrode. Iron can form rust in the presence of oxygen. So there are 2 things that can cause your metals to rust. So you take care of them. You put corrosion inhibitor, you put oxygen scavenger. In the absence of oxygen, corrosion will not take place. Your pipes will be okay. Commercial chemicals. Now, when we talk about commercial chemicals, we are talking about the chemicals we use in mixing our mud. Chemicals we use in mixing our mud, the ones we had into them, the ones we use our money to buy and we put in mixing the mud. One, lime, magnesium oxide. Lime is used for pH. We saw lime mud. Magnesium oxide is good for handling hydrogen sulfide. Potassium chloride is good for inhibition. Soda ash is good for treatment of hardness. You have calcium, you have magnesium in your mud, you have soda ash, it will take care of it. Sodium bicarbonate is used for treating cement. You have cement in your mud, you drill through cement or you case hole, cement is there, put sodium bicarbonate. It will take care of it. Caustic soda is used for pH. It will give you hydroxy ions in your mud and give you some good pH, where your chemicals can work better and where it will not affect, your mud will not affect the metals or rig equipment. Common salt, when we mean by common salt, sodium chloride, the one you use in cooking at home. We use it. Salt mud, to prepare salt mud, and we also use it as brine during completion. Calcium chloride. Calcium chloride, we use it in, is a OBM additives. OBM additives, and also we use it in brine. Calcium chloride is an inhibitor in OBM. It will inhibit, it will pull oil. If you put calcium chloride on the floor or somewhere, when you go back after some hours or after some days, you will see water all around it. It will pull out water from the formation. Why KCl will do ionic exchange, but calcium chloride will go by osmosis. Water will move from a less dense place to higher dense place, to higher density. It will move into the mud. Water will move from the formation. When we talk about water moving from formation, it's not the whole water in the whole earth, just that part that is being drilled. Zinc carbonate. Zinc carbonate too is a form of inhibitor. Calcium bromide, liquid. Calcium bromide too, it's a form of completion fluid, liquid. Sodium bromide is a form of fluid, look for completion. Borax is used for completion. It's a trade name. Zinc carbonate, ammonium bisulfate, sulfite, ammonium bisulfite. All these are commercial solids. We come to OBM additives. This is the second to the last slide. OBM additives. All the other ones will be using water-based additives. If you observe water-based additives, there are so many, but OBM additives are not much. By the time you have 7 chemicals steady, but some chemicals we had in water-based, we also add them in OBM. Organophilic clay. Organophilic clay, organo means it is not mineral, it's organic, oily. That's what we mean. You know, you have your oil base, the base fluid is oil. In the case of water-based, the base fluid is water. You can easily put bentonite and you get your viscosity. You put your polymers, you get a viscosity. In the case of oil, you have to also get a viscosifier for it, for cuttings removal. So organophilic clay is there. Oil wetting agent. Oil wetting agent, you have to add it so that the solid particles, the solid chemical additives you're putting it can mix with the oil and water in an homogeneous manner. It will not be separating, it will not fall to the bottom, it will not settle down. You have rheology modifiers. Rheology modifiers are added to improve your viscosity, your rheological, your carrying capacity properties of the mud, the ability of your mud to carry cuttings from downhole to surface. Those are rheology modifiers you put. You make it finer. to give you exactly what you want. Emulsifiers, I've explained emulsifiers before. They are used to enhance water and oil mixture. They have a polar and non-polar end. The polar end will react with water. The non-polar end will react with oil, thereby bringing oil and water together. Foamer. Foamers are used in situation where you want to become lighter. You can add foamer. The formation is very, very stable. The formation is very, very stable, like rocky formations. The last slide, key performance indicator. Key performance indicator. What do we mean by key performance indicator? What shows that your mold is doing well? What shows that your mold is doing well? What are the things to consider when preparing your mold, when choosing a particular mold for drilling? Number one, cost of chemicals. Cost of chemicals, very expensive venture, and as such, every is geared towards minimizing this cost. And even as drilling must go on to be used, enough logistics plan must be in place such that when chemicals are needed, they arrive before time. Quality of chemicals. If chemical qualities are not good, it will give a bad mold. For example, it will even increase the cost. If you have an emulsifier or you have a polymer that is not working well, you add more and be adding and be adding and be adding. If the chemical has expired, is no more potent, you will just be wasting, you will just be throwing solid into your mold and it will affect your mold. Chemical performance. You need to know the performance of the chemicals. Some chemicals, there are different chemicals. Company A will have a particular chemical, it is working very well. Company B will have a particular chemical, it is also working very well with respect to how they have manufactured it. You as a mold engineer, you have worked for a company A, and now you are working for company B. You have to understand company B, how its chemicals are. If you had 1 pound per barrel, it works. But when you use the other company, you had 1 pound per barrel, you decide for it. So those things also matters. Chemical performance, compatibility. Compatibility means when you bring this chemical, hello, are we there? Hello?
Yeah, I'm right here, sir.
All right, that's the last slide. Just to pause and ask questions before. Okay, that's great. As the slide, we talked about performance. One needs to know the concentration range of chemicals. If I give what I want or not. This says engineer, you must have an understanding. The product, chemical product literature. Can you hear me?
I can hear you now.
Sorry, it was, we're having issues. I think we may need to end the class, but if you have any, that was the last slide. If you have any issues, let me know. Any question?
Thank you so much, sir. For now, I don't think I have any issues until I go through the lectures again.
Okay. That's Samuel. Vincent, how far? Hello, Vincent. How far, Vincent? Peter, are you still there? Okay, let me bring the class to a close.
I'm here, sir.
Okay, I'm about bringing the class to a close. I will continue with the next class. Mod engineering, terminologies and Greek terminologies, rule of thumb.
Okay. Okay, sir. Yes.
Okay, guys.
Thank you so much.
Blessed day.
Thank you.
Thanks.
Yeah, this course is good. I